All right, recording started. Let's go over here. So today we're going to learn about a data type called a list. So what are they? Lists are used to store multiple items in a single variable. So this is really a nice thing to have. It's sometimes called arrays in other languages. Their implementations change a little bit, but Python's lists are very flexible and they have a lot of really nice methods attached to them. So let's go ahead and just get a context. So let's suppose you're looking at your grades and we wanted to go ahead and basically store a bunch of grades, and let's just consider we were to do them with variables. So let's say test 1, you got 100% on. It is the beginning of a semester, you're feeling great. Test 2, all of a sudden things are getting a little hard, but hey, 90 is not too bad. Test 3 was equal to 70.5. We're not doing too hot, but let's go ahead and just consider, how would you find the mean of these? How would you find the average? Well, you would do something like the average is equal to T1 plus T2 plus T3, and then you would divide that by 3, and let's go ahead and print the average. Of course, if we do this, you might be thinking, is that actually going to be the average? Is your average grade really a 213.5? No. If it is, well, you're on your way down if you're thinking the average. What do I need to keep in mind? Your order of operations. So do keep in mind the average here is 86.83. So this is essentially what we've looked at so far in terms of the actual storing of values. But what we want to go ahead and do is, this is kind of like, these are all the same thing, right? It'd be nice if we could group them into a single variable and I just care about their values. I don't necessarily care that there's T1, T2, T3. So instead of doing it like this, what we can go ahead and do is consider grades with lists. And here is how you do a list. So let's go ahead and just say these are we'll just call these your grades, not graders, but grades. And you set a equal to, and you put brackets. And then inside these brackets, you could just list values. So 100, 90, and 70.5. And if you go ahead and just print the grades, let's go ahead and just make sure you can see right there is our list containing 3 values. You might even want to keep in mind, like, hey, by the way, what is grade? So let's go ahead and look at the type of grades, and you could run that. And you can see it is of class list. And what you could go ahead and do is, it has a bunch, let's think about how, maybe a simple problem, how would you then go ahead and compute the average? Well, the average, there's a couple different ways you can do this. How could you access the first element of the list? Well, the way to do it is the same way we did strings. Basically, these are more general than strings. What we can do is do grades, and then we can just access the first one. And by the way, just to make sure you see, let's go ahead and just print, well, it's not the average yet, just run it to see it. You can see it printed that first one. Again, these are 0-based. So with that in mind, how would you go ahead and actually compute the average of the grades that are in this list? Let me give you about 30 seconds to see if you can go ahead and finish off that computation. So the way the rest of this would play out, if you just use the same kind of structure as before, we would need grades of 1 plus grades of 2, and then we, of course, should enclose those in parentheses according to order of operations, and we divide that by 3. So you can see we get the same computation. Are there any questions? Now, there's a few things that are obviously a little bit annoying. Like, for example, how if you think about this code, it doesn't generalize very well. We're stuck with 3 grades. So one thing you can actually do is there is a function in Python called sum. So that's why I've said, hey, don't go ahead or don't use sum as a variable because it's a function. And let's go ahead and just read really quick what it does. If you look up here, it returns the, oops, there it goes. Let's try that again. It returns the sum of a start value plus an iterable of numbers. And by the way, an iterable is just something you can iterate through. So you can iterate through a list, and we'll kind of look at how to do that later. So what we can do is instead of using this notation of just the individual ones, we can just go ahead and pass in this iterable. And 3, again, is hard-coded. You can actually do the same thing that you did with strings, calling the len function, or len, the len function for length, and you could pass in grades. So this right here is, there we go, thank you. So now we can run this, and you can see it gets the same thing. So this is a nice construct that generalizes well. So that's what we're going to be learning about today. It's a good way to store data. We're going to, by the way, be working with a lot of numbers, but lists in Python are very flexible. You actually can go ahead and even put like a string inside of a list too. So if you go ahead and now if I just print the grades, you can see that Python's fine with this. It has 3 integers. Well, actually it has 2 ints and a float and a string. So be very careful with this. If you get some weird errors, it might be type errors because you're not necessarily keeping uniform data. This is not necessarily true for all languages. Like a lot of languages will say, hey, this is a list of ints, and you have to be a little bit more clever if you need to store different data types together. We're going to look at another compound data type later this week called a dictionary, and then we're going to revisit a recursion problem once we've learned about that. So this, by the way, is a compound data type because, again, it is just going to be a type that is built with other data types. So let's get rid of that string there at the end, and let's go ahead and talk about some of the operations that are available to you. Let's say we want, so let's talk about operations with lists. And what do I mean by this? So like in Python, you have things like, let's say if you added strings, if you did A plus B, what does A plus B give you if you were just adding strings? What is the operation? Does anyone remember what it was called? Huh? It would be, your result would be AP, and that's the operation known as concatenation. You're concatenating them, so concatenation, or concatenate. What about if you were to go ahead and do a times 5? What was the operation when you multiplied a string times an integer?
What was it called?
Or just what happened?
5A's.
It would be 5A's or repetition. What if you did something like a string times a string? Did anyone ever experiment with this? A string times a string? Did anyone experiment? Well, best part, there's really no cost in experimenting. It's a type error. That operation between strings is not defined. So again, it's always a good idea to think about how you can go ahead and put, how you can operate with lists. So some of the other operations that we have are grades. What I want to do is update it with more values. So let's say the addition is going to behave in a very similar way as it did with strings. So let's say they got a 70, let's say they got a 50, and they were a rebel and did not show up for the last test and got a 0. So let's go ahead and print grades now. And you can see what we have is the concatenation of the 2 lists. So we had our initial grades, and we wanted to go ahead and add more values to it. So we just added it like so. And by the way, if you just wanted to add one element, you can always go ahead and just do that. You can see right there, you get 0. So addition between lists is concatenation, very similar to strings. Good? What about, we also, again, let's see what, we also, what about multiplication? So what if we were to do, question, Kenneth? Okay. What if we were going to do multiplication? So let's say 1, 2, and just kind of look at what happens. Notice here, there is, just like strings, there is no multiplication between lists. But what if we were to go ahead and multiply it just by an int? What if we did a list times 2? Look at what we get. Repetition, just like we did with strings. So you can see we had the first list, and we just repeated it right there. So let's go ahead and leave grades right here. What if I want, let's see, is there anything else I wanted to say right there? No, that's good right there. What if I want to go ahead and get the last element from the list? What if I want the last one? If you notice, these are acting pretty much like more generalized strings. Anyone think they would know? How would I go ahead, and if this was my grades right down here at the bottom, how would I go ahead and get this last 70.5? I would index using -1. So again, you can just go ahead and just do a -1 in here, and that allows you to go ahead and get the last one. Indeed, you have all of the same indexing and slicing options. You have slicing. So if I did 1 to say 3, and again, before I do that, let's just print grades so you can see it. So put that here really quick. If I were to go ahead and print this now, anyone think they could remember what would print if I did grades and then slice to 1 to 3? It would be the first value, which would be 90, and then of course the second value, which would be 70.5. Would it include the third value? No, remember it is a strict inequality, or is half open, so it's open on the right. So you have all of those indexing. All right, so any questions about the basic operations with lists? Okay. So let me back up right here, and if I were to go ahead and just do grades equal to 0, let's throw another 100 on there. Why not? This is I need to print that. Print grades. So this is a little bit of kind of annoying syntax, right? And there's also, like, if you are not familiar with the language, I mean, yes, you can do also something like plus equal to 100. Like, if you did not know Python, like, you'd look at that and be like, what is it doing? So there's this is not the best way to go ahead and add items to the list. The best way to do that would be with a method called append. So remember, a method is accessed using the dot notation, and you can just go ahead and do append, and now you can do 100. And if you just think about it from a readability standpoint, this is much more obvious. I have a list of grades. I'm going to append, and append means just to add on to the end, 100, and you can see right there, we do get the same value when we run this. So the append is a good way to go ahead and actually put elements into your list. Notice that it does put it at the end. There are other methods, like for example, there's an index method. If you wanted it at the beginning, you can see that there's not an index method, an insert method that basically says, go ahead and insert the second number at index 0. So you can see right there, that 100 is now at the beginning. So just like whenever, I always recommend that whenever you look at a new data type or a new library, if you would continue your learning after this course, always just go ahead and look at the documentation, and you can see what you have access to. So you can see we have a bunch of different methods. Let's see where those are at. Where are the methods? Don't pick that website. That did not. I would always technically, tutorials point is good. The official documentation is also good because they also This builds right off the doc string. So the official documentation is essentially the doc string that you'll see. Not the most readable, but you can see there are a ton of methods with lists that we'll go ahead and explore over the next day and probably into Wednesday as well. So again, any questions on lists so far? All right. So let's go ahead and talk about the idea of, let me go ahead and just show you a couple other characteristics of lists. Lists are mutable. So does anyone remember what it means to be mutable? Or strings were immutable. What did that mean? They couldn't change. Lists are mutable. So for example, like if we have our grades, which again, we're right down here below 100, 190, 70.5, and you know that 70.5, just like, hey, I needed full credit on that one. You made a good argument, and you wanted to go ahead and adjust this one right here. Well, you asked for a regrade, so what you can go ahead and do and say, okay, grades of -1. Again, that gives you the last element of the list. And let's say after a good talk where everything was respectful, it was a good conversation between the student and the professor. Subtlety, right? You go ahead and they... I need to go ahead and print this again. You go ahead and have that good conversation. The professor adjusts the grade. And you can see, in this case, lists are mutable. You can grab a specific item in the list and update it or change it. So this, again, was this top one is before we changed it. And then line 18 executed. And you can see lists are mutable. We're going to learn about tuples. Probably maybe next class we'll talk about tuples. Tuples are immutable. They're basically the same thing as lists, but they can't be changed. So those are good for if things can't be adjusted. It kind of protects certain data types or protects certain data. Anyway, lists are mutable. That's good to know. There are a couple of things you want to be careful of, though, when changing it. So let me just comment this out right here and talk about the wrong way to adjust lists. So, for example, if we were to do maybe you're thinking like, oh, okay, I need to update grades, and you do something like grades.append, and let's say you were to go ahead and do 100 right here. So, no, we're using 100 too much. Let's do 50. Why not? So if we look at this, and when we're done here, now let's go ahead and print grades. Let's look at what happens. The moment of truth. None. That's weird. Be careful whenever it comes to how you're doing this. Append, if you look at its type hint right up there, do you see it takes an object, which is, again, object of type _t, is basically just said it will take pretty much anything you want to give it, whether it's a float, an int, but look at what it returns. It returns none. And that's because the append method operates in place. It does not return a new data structure. It just takes the one that it's working with, which is grades, and it just does it in place. So keep in mind that what you do right here is this grades returns none. It appended it, but then it overwrote it. There we go. So be careful with this, that this return, so this actually appended it, but you overwrited it with none, which was the return value of the append function or method because it's attached to a data type. Another thing that you might do that is wrong would be, let's see, I have another one here, grades plus 42. Let's just do 50 again, whatever. Notice this one is not going to update it because this is the one where it basically is going to operate and going to return. So you can see right here, grades was not updated because this is the scenario where you need grades equal to grades plus 50. So be careful not to merge those two different methods, or because they do handle the appending of the new element different ways. There's also one other thing that you might do wrong, and that would be this. What happens if you go ahead and just try to add an int to grades? It's a data type error. The addition between grades and or a list and a int is undefined. So careful, those are a couple mistakes. Here, let me go ahead and put the other one back up here just so you have it for reference. So that is wrong, and also grades plus equal to grades plus 50 is wrong. So a couple things to be aware of. Any questions concerning kind of the appending to lists? Nope. All right. Let's go ahead and let's see. By the way, just moving forward, we have grades 100, 100, 90, 75. Let's go ahead and change this to a 99 just so we have a nice variety. So the next thing I want to go ahead and talk about, a lot of these should be intuitive, iterating over a list. A nice way to do this, but there are a couple of gotchas here. So again, we do want to be careful with certain ideas about iteration. So you have the same idea for grade in grades. You can go ahead and just print the grade. So again, you could do your standard iteration. So you can see the first one is just, no, let me just put this here. So print our grades are, and we'll just do that. Just so we can keep in mind what the actual data, so there we go. Okay, so you can see we can iterate over it like that. And what we want to go ahead and do is, remember this right here, is just going to define a new variable called grade, and each time through the loop, it's going to pick the next value in the list. So that's a good little thing to keep in mind. But let's go ahead and let's do a little bit of a exercise. I feel like I've been doing a lot of talking today. So let's go ahead and do an exercise. So the exercise is going to be as follows. This is actually going to feel very similar to your first project where you had to keep track of things. So let's go ahead, and the exercise is going to be as follows. All right. Write a program, and again, you could encapsulate it into a function if you want, but basically the exercise, write a program that counts the number of A's, B's, and C's, and no, let's do A, B, C's, and failures, and fails in a list of grades. Okay, but I did not, instead of, let's not make this problem trivial. So in order to get us set up, let's go ahead and import random, or excuse me, let's do it like this. We only need one function. So from random, import rand, let's go ahead and import rand range. Remember, technically this should go at the top of the file. I'm just doing it here to kind of pretend this is the top of the file. I'm just leaving this here for notes. So what we can go ahead and do, let's go ahead and populate a list of grades. And there's a couple ways you can do this, but I'm going to go ahead and make an empty. I'm going to overwrite my grades. I've made an empty list. So again, empty list is just square brackets. And what I want to do is for I in range of 30. So I want to go in, I want to put 30 in. Technically, I mean, if you want, we don't even need this I. We just want to repeat something 30 times. So I'm going to just use the kind of the placeholder underscore. Grades, I'm going to append to it some random range. And this right here, I need it to be, I'm using the random range because it is going to look at what it does. Choose a random item from range of start to 0 to step. And so let's go ahead and do from 0 to, and you can even see right here, let's see. So int start, so start at 0, and let's just assume there's no bonus points. This fixes the problem with random int, which includes the endpoint. So you might actually need to actually bump this up to 101. I think that changed since last time I used that function. But let's go ahead and see what happens here. Let's go ahead and print our grades and see what we get. Print our grades. Let's run this. Yeah, so so you can see right here, I have a list of dummy data right here. By default, I think they are distributed uniformly. There are other, if you wanted to do something with, so this would be good if you ever want to just experiment with data. If you need a certain distribution, there are other functions that return something per a certain distribution. And again, that's outside of the scope of this course a little bit. But so there's my 30 numbers. Now let me give you a few minutes to actually go ahead and see if you can do the exercise. That is to say, go ahead and write a program that counts the numbers of A's, B's, C's, and we'll just do D's and F's together and fails. I don't know if they're actually both fails, but
like there were X many A's, X many B's.
yeah. So ultimately, what we want to do at the end, so we're basically going to do stuff. This is the exercise, and then when we're done, we should go ahead and print something like A's, and we can do like num of A, and then we can print B, and we can do num of B. So you might want to have some placeholder variables and things like that. So yeah, let me just give you a minute or two there. And breaks up the day a little bit. Oh, and I'm going to go ahead and also import seed, and I'm going to go ahead and seed this grade with this generator with 1, just so if you guys want the same answers as me, just add on line 34 and 33 the seeding, so if you want the same answers. I just picked up. The seed is just going to be some int. Say again?
What's failing? Rule 60?
Whatever you want to do, it's your exercise. Yeah, I think when I did it, I had my as a 10-point scale, so I did like 90 to 100 is an A, then 80 to 89 point. I just use strict inequalities, so. Oh, it's me. In my program, an 89.99999 is a B. So. But I didn't want to deal with rounding and stuff like that. Could do that. It wouldn't be hard to just round it using the round function, but. All right, so I'm about done with my logic. I'm just doing some printing up here to go ahead and print my results. So we'll go over this briefly, and then we'll look at a few other things related to strings. So fails, let's see, num fails. All right, let me run that, see what I get. Ooh, this was not too hot. Obviously, this is I think it's using a uniform distribution by default. So obviously, since there's a lot more gap, or at least a range right there for the 0 to 60, or 0 to 70, so that's why there's so many fails here. You can go ahead, and I believe there is if you were doing this and needed some just random data that actually fit this kind of context, you of course would want to find some sort of normal distribution. But the logic is as follows. I have some variables up here that start at 0, and then I have some logic that basically will just increment the appropriate counting variable based off of the compound inequalities that we have access to in Python. Again, if you don't have access to this compound, like if you're programming in Java or C, or a lot of other languages don't have this nicety, the more modern ones do, because it's the cost of compilation and interpretation is going cheaper as computers get faster, but that's beside the point. You can always use logical ORs or ANDs and things like that to do these without compound inequalities. So, does anyone have any questions on that, or anyone kind of get there? Yeah, Anna.
Actually,
No, get it? By the way, isn't this whole thing remember when we started this lesson, we're like, hey, let's store a bunch of values and variables and then do one piece at a time? Isn't that kind of the same issue we're having here? We have a bunch of these values and variables, but the reality is we're just going to go ahead and kind of tie them to some numbers anyway. At the end of the week, we're going to talk about a dictionary, and a dictionary allows you essentially to create an association. So you could have basically a dictionary, and then in that dictionary, you can have a key of A, a key of B, a key of C, and then you can basically update the value, and all of this could be essentially encapsulated into one variable. So that's a little bit at the end of the week. Just wanted to kind of drop that in your mind right now. Does anyone have any questions before we kind of look at a few other odds and ends about lists? Yeah, Anna.
I do have a question about the seed. What is that? Does that just
About what? The seed.
Yeah.
Yeah, so if you analyzed in project 2, if you look at the utils.py, there is a seed right here. And basically, when you seed a random number generator, it's going to basically grow the same way every time. Hence, it's called a seed. So this isn't random, because if I run this every time, notice that I get the same results. But if I were to not seed the random number generator, you can see each time I run this, it is picking a different seed. And I don't know what it actually, I might be able to print seed. No, I don't know. I'd have to look in the docs. You actually could probably, but that seed is usually, unless if you tell it what it is, the computer is essentially using some internal things to try to make it appear random. So it might be using something like the clock time. It might be using the high security ones will even use things that are in the world, for example, the temperature of the room. There might be a piece of hardware in something that basically says, hey, I'm going to generate my random number using this piece of data. I just did a security class last fall, and there was a major security issue in in a random number generator they were using for some security, and basically it's because it was it was taking some time before the randomness started. So if you actually got in and did the hacking within the first minute, it wouldn't be random because it always started the same way the first minute. So you got to be very careful about it. And there's a lot of smart people that work on very interesting projects when it comes to randomness, because it's still just an algorithm at the end of the day. But anyway, long answer for a simple question. Sorry, that tends to be how I do. All right. So let me just go ahead and comment this out so we can, again, just have this here for reference later. But let's go ahead and talk about a couple other things you want to be careful about. Let me just run this. Okay. Let me go ahead and even comment this out up here. Or again, I'm just pretend I'm at the top of a file. All right, so let's. All right, let's get a new context. Let's just talk about taxes. You know, everyone loves taxes, right? That's a lie. I don't want to pay mine, but I don't know. We haven't done it yet because I'm afraid we owe. But we'll get to it before April 14th. Anyway, let's say you are shopping at the dollar store, which is now turning into the $1.25 store, but whatever. Let's say you're shopping, and no, let's forget the dollar store. Anna, you go shopping. What do you buy? Not a trick question. Grapes. You buy grapes. Grapes nowadays cost what? $5.90. $5. Sounds good. Okay. All right. Someone who actually knows what they want to buy. Bailey? What do you want to buy?
I was headed in a completely different direction, but flower pots.
Flower pots. How much do flower pots cost?
It's at the dollar store, like
$3. Okay. All right. Someone else. Who else wants to go shopping? Patrick, what do you want to buy? Fruit. You and Anna buying fruit. What kind of fruit?
grapes for sure. I feel like grapes are good for
We already have grapes in our shopping basket. Bananas. Okay. How much are bananas cost? Those are cheap. I think those are like 89 cents or something like that. So, okay. So you go to check out and you're like, okay. The cash register says, okay. I want to go ahead and. Let's see, the cash register does this math, and you're expecting it to say $8.89, but that's not what the cash register says, because sales tax. So we need to go ahead and figure out what we needed to actually do. We need to go ahead and update the prices, right? What is sales tax? It's 7 cents down here, right? Still? 7%. So you might think about this for price in prices. Let's go ahead and just do price times equal to 1.07. You think that would do it, right? I'm just going to take each price and multiply it by 1.07, and nothing changed. Whoa, wait, hold on. Let's go ahead and print our prices and it should have changed, right? It didn't change. And this is one of those things that if you're not aware of will get you when you're working with lists. And I did say lists are mutable. You should be able to change them. But if you're going to change them, what you need to do, I'll go ahead and just write it here in a comment, is you actually need to use the indexing to go ahead and change prices. So use indexing when modifying elements. So what do I mean by that? You're going to have to unfortunately do this kind of less Pythonic way, but say like for I in range of length of prices. And again, remember, this is going just to remember what it looks like. If you print I, this is going to just print 0 through 3. 0 through 2, because range is not half opened. But now what you can do when you have these is you can go ahead and do prices at index I times equal to 1.07. And that is actually going to go ahead and do that. So be very careful when it comes to lists when you're trying to modify them, because if you're going to actually modify the values, you do need to actually call or iterate it through using indexes and not the in operator. So a little bit of a thing to be aware of there. I have fallen into that and banged my head for 3-4 hours just to realize like, oh, that doesn't work. Yeah, Kenneth. Different ways. I was using this as a context to illustrate the point. Yes, it would be much more efficient to go ahead and just multiply the sum, but I just wanted to provide some context and say, let's just multiply random numbers. So, yeah. So, and I mean, if you're actually programming a cash register too, you're not waiting to the end to do the taxes all the time. I don't know. I haven't looked at a receipt lately, but yeah, sometimes like certain taxes will say, this is this much, or it might just do a subtotal. I don't know. Depends on what your client wants is when it comes down to it. with that in mind, let me see. I think there was like one more thing or two more things I wanted to look at today. Oh, yeah. Okay. So, all right. So let me go ahead and erase this. We've been dealing with a lot of numbers today, so I did want to do something that was not numbery. So let's go ahead and do let's just declare a variable called my shopping list. Let's see, what did we get? We got grapes. What did you get, Bailey? Flower pots? Okay, flower pots. And Patrick, you got bananas? Okay, so we have this right here is my shopping list. And we'll go ahead and consider, suppose you want to check if something's in there. So you don't necessarily have to iterate through and check each thing. What you could just do is say something like, if cake is in my shopping list, my shopping list, print yum, else I'll print boo. And you could run this, and you can see you don't necessarily, it's kind of behind the scenes iterating through it. And again, this is kind of getting in the idea of searching, and which we're going to look at more next time. But again, this is just making sure you're aware of, like, you can check if something's in there. So let's say if we say grapes are in here. I mean, grapes are still yummy as long as they don't have seeds into it. Let's see. So if grapes is in, yes.
What's going on with the commas in the? Yeah.
That is the typo I was about to run into, because again, I missed the commas. But if you look at this, if grapes in my shopping list print yum, I messed up here. I forgot. I forgot quotes here. So good catch. I noticed that right now. So let's fix that. And now this should print yum because I did not have that in that print. So if you're iterating, just throwing this out here, kind of getting ready for the next project in my mind and kind of starting to drop some hints on them. So if you're iterating through, notice if you're checking like strings, you do need to be very careful, because even if this was just like S, or like there was an extra, like let's just capitalize the S there, all of a sudden that's going to print boo. So you might need to be careful with that in terms of some data setup. Any questions on that one? All right. So you know what? I had one more exercise to do, but that was a pretty good day. I think we're going to spend next class. We're going to spend one more day with lists and maybe talk about tuples, and then at the end of the week we're going to talk about dictionaries, and then we have some compound data types to work with. But does anyone have any questions about what we discussed today? All right, I'm going to stop the recording, and if you have any questions, feel free to hang out.